Well, we're not going to get to linear programming, but we're going to sort of set up something that's like linear programming. And that means I get to start a mixed nuts. This is number 60 on page 914. And it's for mixed nuts. Okay, so you got these mixed nuts, and you're got cashews and peanuts that you're going to mix. So, if we read through the whole thing, you'll get down to the end, and what they're asking you to find is how many of these packages that they're going to make. They're going to make 12-ounce packages of these things. So we need ounces, in a sense, and X is going to stand for the number of packages of cashews, and Y is going to stand for the number of packages the peanuts you can make out of the peanuts, because they have a total of 90 pounds of cashews and 120 pounds of peanuts that's available. Now those are pounds, and we're going to make 12-ounce packages. So we're going to have to change all these to ounces. 120 pounds is 1920 ounces. I'm sorry, 120 pounds. Oh, shoot. It's 1920 ounces. And 1440 is the number of ounces for the 90 pounds. That's a 1920. Hope you can read that. But you just take 120 times 16 ounces per pound, right? So we need some restrictions on this. Cashews is the number of packages. One of our packages that we're going to make is going to be, these are 12-ounce packages. So one of our packages we're going to make is the cheaper brand, which uses, for the peanuts, 8. Let's see if this is what. Okay. This is not true. This is the number of packages of the cheaper stuff. So it's not cashews. Take that back. So there's a cheap one. We'll call it Mix 1, and a more expensive one, Mix 2. And X is going to be the number of packages for that, for Mix 1. And Y is the number of packs. So I got to make sure I've read my problem correctly. Not for the amount of cashews in each. We just have 1,440 ounces of cashews and 1,920 ounces of peanuts available. But the mix, X and Y, is going to be what we're going to use for our variables, the number of mixes, these packages we can make, these 12-ounce packages. So, if you have, it says in here that it takes, for Mix 1, it takes 8 ounces of peanuts for that Mix 1, and it takes 6 ounces of peanuts for Mix 2. For the cashews, it takes 4 ounces of cashews for Mix 1 and 6 ounces of cashews for Mix 2. So, or 6 packets per package. That's X and Y are the number of packs. Now, these ounces, for the peanuts, we have a total, so we can have up to, for the peanuts, 1,920 ounces. 8 ounces, 6 ounces, number of packs. And we can have the 4 ounces and 6 ounces for cashews for these number of packs, but we have 1,440 ounces. Okay, so those are the two restrictions we have on these cashews and peanuts. And that's what we're going to graph. We have to recognize that we're only using the first quadrant because you can't have a negative number of packs for the for mix 1 or a negative number of packs for mix 2. So now we're going to have to divide some of this stuff. The 1920 divided by 8, because that would be the number of for X packs that you could fill up here, is 240. And take the 1440 divided by 4 and you get 360. For Y, the 6 divided into 1920, because you want the y-intercept, is 320. And the 6 into 1440 is 240. Okay, so now we know the x and y-intercepts. But I'm a little concerned that these are 12-ounce packages. So each of these really, the number of 12-ounce packs. So what we need to do is graph these, because this is once again the number for mix 1, that's their 12 ounces for that. The number of mix 2, that's your 12 ounces for that. More peanuts in the cheaper priced one. So, okay. We're going to this is going, see, X goes up to 360. Half of that is 180. Half of that is 90. And then, of course, 270. The maximum number is 320 for the Y. So 160 is half of that. What do we need here? Half of this is 80, and this is 240. Let's graph peanuts. 240 on the X, that's around here, and 320 on the Y, that's here. Okay, that's graph 1. We want to be less than that. 0, 0 makes that true. For the cashews, 360 and 240. So that goes something like this. So that's graph 2. We want to be less than that. And of course, we're in the first quadrant. So it's all this stuff in the yellow. Now, what they want us to do, preparing us for the next section, which we're not going to get to, that has linear programming, they want us to label the corners, the vertices of this, in this case, a quadrilateral. And the vertices are 0, 0. This one, remember, it's the 240 for the X and 0 for the Y. This one, that is the 240 for the Y and 0 for the X. This one, we've got to solve a system of equations. So And we solve that in a lovely shade of green. We take 8x plus 6y equals, now we're doing equals because we want to know exactly on the lines, 1920, 4x plus 6y equals 1440. If we want to solve this, I would say elimination is best. Change all the signs for this second equation. So this is 8x minus 4x, which is 4x. These two cancel. That's what you want. So 0 minus 0, 12 minus 4 is 8. 8 minus 4 is 4. And x then becomes 120. So we can make 120 of mix 1. And if we use either one of these, x is 120 plus 6y equals 1920. What's 8 times 120? It's 960 plus 6y equals 1920. Let's make that negative and add it to 1920. 960, I thought so. 6y is equal to 960. And take 960 and divide it by the 6. So y is equal to 160 packs of that mix 2. And 120 packs of mix 1. Okay. Oh, that's just where they cross. 120 and 160. Now, what we're doing, and just, we're not going to do this, I guess, but in the next section, they talk about linear programming, which is exactly what we've done here. And what you do is you use these points, because one of these points will be a maximum, or one of these points will be a minimum. I bet you the 0, 0 is the minimum. And I'm not sure, it could be the maximum depending upon how much we get out of this. But we'd need another equation like a profit equation in order to figure that out. But we're not doing that. But you need to be able to use this to solve some equations. There'll be a problem like that on the test. But that's all of section 12.7. That's all of chapter 12.